Welcome to Pipeline Conversations, a machine learning podcast by ZenML. I enthusiastically read Kush Varshney's book when it was released for free to the world several months back. Trustworthy Machine Learning is a concise and clear overview of many of the ways that machine learning can go wrong. And so I was especially keen to get Kush on to talk more about his work and research. I also got a stronger sense and appreciation for how good MLOps practices and workflows offered a clear path to ensuring that your machine learning models and behaviours could become more trustworthy. Kush has done a lot of interesting work, particularly with the AI Fairness 360 and AI Explainability 360 toolkits that I'm sure listeners of this podcast would find worth checking out. But without any further ado, let's get into the conversation.
Thanks, Alex, for having me on the podcast. My name is Kush Varshney. I'm a distinguished research staff member and manager at IBM Research, working at our TJ Watson Research Center, which is in Yorktown Heights, New York. And I focus on what we call Trustworthy AI. So that's the idea that a lot of the models that we want to put into production from machine learning and so forth, when they're used in high-risk applications, we actually care about a lot more things than just their accuracy. So we want to care about things like fairness, robustness, explainability, transparency, and so forth. And the way I got to this point is when I first started working at IBM Research after I'd completed my PhD, was that we did a lot of applied projects with various sort of organizations who were using machine learning in new ways at that time. So back like 12 years ago. So many of them were related to some sort of people processes. So HR sort of problems, healthcare problems, etc. And by working on those problems, and then I also co-founded the IBM Science for Social Good initiative, in which we started doing a lot of applied projects with various nonprofit organizations and social enterprises. When I first started working at IBM Research, after finishing my PhD at IBM, we were actually working on a lot of applied projects with various organizations. So that included organizations looking at HR applications, so promotions, retention, hiring, things like that, as well as many healthcare sort of applications. And by working on those projects, as well as some projects that we did through a program that I co-founded called the IBM Science for Social Good initiative, where we worked with various nonprofit and kind of social enterprise partners, we kind of learned about what are all those considerations that you have to actually have while putting these models into production in those high-risk sort of settings. So that's kind of how we got to the point that we did, and then started focusing our research on some of those topics as well.
And what was it that kind of specifically attracted you? I mean, a lot of people work on applied projects in healthcare or whatever, but not all of them end up writing books about, trustworthiness in machine learning. Like, what was interesting for you?
Yeah, I think I've always had an interest in the broader impacts of the work. So back in school, I did, major in engineering and so forth, but I always kind of in high school and even throughout college was always interested in kind of other topics in the social sciences and so forth. So I think that has played a role. Also, I think being in a research environment at IBM Research, where we have a dual sort of mission, both to satisfy the client needs, but also then think about where we can take that further, was a big contribution as well, because it's not just about doing, it's not just about researching, but kind of basing the research on what we have done. So I think all of that combines to take me in that.
So maybe it's worth just getting into the book a little bit. I have, somewhere in between skimmed and read it. Some parts of it went a little bit over my head, a little bit too technical. Other parts definitely would, even if you're non-technical, I feel like it's very clearly written and clearly presented. So thank you for, it's clear you took a lot of time to make sure that it was consumable in that way, I guess. But yeah, maybe you could just talk about the the thesis of the book, talk a little bit about what you exactly mean by trustworthy, unpack that a bit.
Yeah, sure. So the book is entitled Trustworthy Machine Learning, and I'm self-publishing it, so it's available for free as an electronic copy at trustworthymachinelearning.com and an at-cost paperback via Amazon in their international markets and so forth. So, so the book is about, like I was talking about earlier, kind of what are the considerations that we need for people to be able to trust these AI systems as they're being used in various sort of high risk applications. So the way that I kind of thread everything through the entire book is first by defining what I mean by trustworthiness, and the starting point is some of the literature from organizational management. And in that space, they've identified four main attributes that another person needs to have to be trustworthy. And I kind of uh, start the discussion in that way. So those four attributes are that the other person should be competent at what they're doing, so they can do what they say. Second is that they should be reliable, so that competence sticks around in different conditions, different settings, and so forth. Third attribute is some level of openness or intimacy with the other person, so that you can really communicate back and forth with them. And the last is some kind of selflessness, so that the other person is working not just for their own goals, but for some broader mission. So the way the book kind of proceeds is by kind of mapping all of those attributes to actual characteristics of machine learning systems, and then talking about those in some detail. So the competence is the basic accuracy. So how do we make systems that perform well? And then the reliability maps to a few different things. So there's distributional robustness. So we don't want machine learning models that fail when there's data drift and so forth. There is algorithmic fairness. So when we are applying these models, we don't want them to perform very differently across groups. And individuals, so that we want them to be performing well across all people. And thirdly, it's adversarial robustness. So we want these systems to be able to withstand any sort of malicious attacks that are usually some sort of causing of a distribution change or something like that. So we want that reliability as well. Okay. So that was the second attribute. Third attribute is the openness. And so there's the direction from the human to the machine. So that's what we would call value alignment. So value alignment being the idea that how can we as people instruct the machines to behave in the ways that we want. And then there's the direction from the machine to the human. So that includes explainability and interpretability of models. So that's how can people understand how the machines make their decisions. And then there's also a broader set of things that go beyond just the model interpretability. So that includes how do we test these models? How do we report those test results in a transparent manner? How do we compute uncertainties associated with those test results and so forth? So all of that is the third attribute. And then the last attribute is how do we use AI for social good? How do we include the values and perspectives of people who have experienced marginalization in some capacity, and actually make these systems so that they are empowering of all people, including those who have experienced some sort of oppression before. So that's kind of the overall sort of framing of the book, and how I kind of tried to go through things.
What level were you trying to address by writing this book? Was your goal to affect like kind of practical change, just reframing the way people think about these things, offer people a framework, all of the above?
Yeah, so I mainly wanted to appeal to people who are in the trenches, so project managers and data scientists and data engineers who actually are working on problems that have some consequence to them. But I didn't want to make it like too superficial, in the sense that I mean, everyone would agree. Yes, I mean, these are important topics. I don't think that that's necessarily something that we need to convince. But what we need more of is kind of the conceptual understanding of what these really are and kind of how they're interrelated, how to work towards them. And the other thing I didn't want to do in the book is just make it be kind of like a recipe book that these are the steps to follow, and do this, do this, do this, and then you'll get what you need. Because to me, I mean, another sort of thing that I say throughout the book is not to take shortcuts. And what I mean by that is that it's very easy to kind of not think about what you're doing as a developer and kind of just follow a prescribed pattern. And I don't think that's the right thing to do in this space of trustworthy AI. So, what I want people to understand is what are the concepts. Have enough details so that it's not just like wishy-washy, but I mean grounded in sort of reality. But then um, uh, I mean, there's other resources for like a really deep technical dive onto things, code examples, things like that, or elsewhere. But like kind of having the vision for people of what to think about, how to think, so that when they are in actually developing their systems, whether it's in any industry, banking or healthcare or retail, or I mean any sort of place that you are developing machine learning models for, that you kind of have this way to think.
Yeah, I think that the ways all of these different concepts and ideas interrelate to each other was one of the big things that I took away from. I've got my kind of heavily annotated now copy. Yeah, because I think quite often you hear these words in disconnected ways, and
Yeah.
sometimes people don't use them in a very clearly or well-defined way. So
Mhm.
there's often a tendency to blur, in between.
Exactly. So when we talk to a lot of customers and clients, they might use the word explainability when they really mean fairness, and vice versa, and so forth. So, getting the concepts across, I think, was important for me, because there are reasons why, I mean, different things are more or less important in a particular application. So, having that clarity, I think, is a good thing.
It feels like also that, I guess, of these four main areas that you explore, it feels like most of the effort, at least so far, and maybe this is my misunderstanding of the space, but most of the effort has gone towards the competence part of things at the
Mhm.
detriment of the other three. Firstly, I guess, is that a correct assessment?
Yeah,
And is that
absolutely.
just because it's easier somehow, or like,
No,
yeah?
I mean, I think that's how you have to start, right? So that is definitely the right sort of understanding. And one analogy I like to make is to aviation. So we can say that the whatever the first flight by the Wright brothers was in 1903, and the first 50 years or so were just about figuring out how to get planes to fly. And then in 1958, that was when the Boeing 707 was introduced, and since then, planes haven't, I mean, changed radically. I mean, they kind of are the same as they were in 1958. So, in the second 50 years that have transpired since then, the big change has been around the safety and automation of aircraft, right? So, since the 1970s, for example, the fatality rate is like 300 times lower per mile flown, and there's, I mean, so many more planes flying and everything. So the safety, the trustworthiness has to come after you kind of figure out the basics of how to get these things to fly, right? So we're kind of now at this beginning of the second 50 years of AI in some sense. So again, if we go back to like 1956, the Dartmouth Conference, which kind of launched the field of AI as an area of study. And then we can say maybe around 2012 or so was that first 50 years when ImageNet was sort of beaten by deep learning and so forth. So now we're right at the start of that second 50 years where now the focus is on all these other considerations.
Where do the incentives or motivations for that switch to come? I mean, I can see in certain areas, I guess maybe you were talking about high risk areas earlier on. I can
Mhm.
see maybe there's a little bit more of an incentive, but for a kind of a wide scale change, does that exist even?
Yeah, I think things are starting to happen. So especially with regulations. So in Europe, there's the draft regulation for high risk AI that should be in effect pretty soon, and that's going to kind of insist on various sort of fairness and explainability and robustness things for any for a lot of AI systems. And around the world, there's a lot of new regulations coming out in different sort of industries, but uh, also, I think there's a few other reasons. So, a lot of companies are now thinking about their brand reputation. If there are factors that lead their systems to behave poorly or in bad ways, in harmful ways, then they don't want that to happen. There's a lot more complexity these days as well. So there are organizations that have thousands of models running, and just making sure that they're well governed, well tested, and so forth is an important aspect. And then in the last couple of years, in many parts of the world, there has been a renewed focus on social justice as well. So I think that's playing a role. So everything is kind of coming together. People now are actually interacting with these systems in their daily lives. So I think it is time now to focus on all of the considerations beyond accuracy just as much as we do on accuracy.
Do you foresee, I guess, a little bit like your aviation example, do you foresee some of this complexity eventually being concealed away, maybe to the point where it's not, it's just being dealt with automatically, or are there some parts of this stuff that just is complicated and will remain so for a long time?
Yeah, so let me continue my analogy a little bit. As much as I know about airplanes, there's kind of three parts of a flight. There's takeoff, there's cruising, and there's landing. So the cruising part has become very automated. So the pilots, I mean, put things on autopilot and so forth. There's much more manual sort of parts of the takeoff and the landing. And if we think about the entire sort of AI development lifecycle, there are kind of different phases, right? So there's the problem specification, there's data understanding, data preparation, modeling, evaluation, and then monitoring and deployment. And so we can kind of think of a few of those parts as a takeoff part. So things like specifying the problem, also understanding the data. So I think those have to be kind of kept manual in many respects.
Mhm.
But then the middle part, which is the data preparation, feature engineering, and modeling, a lot of that already is becoming automated. So there's a lot of auto ML sort of things happening.
Yeah.
So I think that will continue, and it can bring in a lot of the fairness and explainability and robustness and other things because those are additional constraints, additional objective functions for the AutoML to also worry about. So that is happening. I don't imagine that it will be, I mean, even more than a couple of years before all of these things are incorporated into AutoML sort of systems. And then the landing is kind of the evaluation, the monitoring in some respect, but evaluation mostly, which does also need a human touch to kind of identify what are the possible harms that the system might be enabling and so forth. And especially bringing in people who have lived experience of marginalization to better be able to recognize what those harms are in that evaluation phase. And then in the deployment monitoring sort of thing, I think also there's a lot of possibility for automation because, uh, again, I mean, there's if you have well-defined sort of metrics and things, you can kind of monitor things in that appropriate fashion. So I think there's certain parts where there will need to be more of a human aspect to it, but there's certain parts that can certainly benefit from more automation as well.
It seems at the moment there are a lot of people coming into the field of machine learning, quite a few of them coming from, you know, very distant disciplines, which in some ways is a good thing, I would argue. Possibly, though, I wonder whether a lot of untrained people doing things with a tool which isn't really built towards best practices, and a lot of the things that you write about in your book, it feels like almost like everything is kind of a high risk domain in that
Mhm.
sense.
Right.
would, would you agree, or?
Yeah, I definitely agree with the sentiment that you have, and it's more of a call for us to develop better tools, I think. So, if we are going to be democratizing a lot of the AI sort of stuff, going more towards these low code, no code sort of environments and so forth, we can't do them kind of blindly. I think it's an onus on folks like me or other people developing tools for citizen data scientists to actually put in guardrails, mechanisms for governing these systems such that you actually aren't allowed to, or at least be warned very seriously that the system that you're creating actually is going against certain sort of levels of things that you want to control. So I think the governance aspect of it is the key. While we're making things easier to use, we can't kind of get away from the responsibilities. We can't absolve ourselves of those guardrails and so forth.
So it seems that at least at the kind of the lower level, maybe bottom up, yeah, improving that tooling space is important. What would be some of the tools and kind of bottom up standards and
Mhm.
processes, I guess, that you think are getting it right or going in the right direction at the moment?
Yeah, so my own group at IBM, we've created several open source toolkits. So AI Fairness 360, AI Explainability 360, adversarial robustness, uncertainty quantification, AI fact sheets as well, and privacy and causal inference. And with all of those, right now, they're just, I mean, Python libraries, or in the case of fairness, there's also an R library. And they don't have all of this other stuff that I was just talking about, right? So one thing that, at least on the IBM side, we're working with our product group with is actually to institute more governance around kind of the development lifecycle. So there's an IBM product called Watson Studio and Cloud Pak for Data, and in that we just kind of pushed for an AI governance aspect to it, which is based on our fact sheets sort of ideas. And that actually starts the process of people actually being explicit about what do they care about, what metrics do they want to put bounds on, and so forth, and does some automatic collection of what's going on and so forth. But I think there's a long way to go. I think even that is maybe too technical right now. So, I mean, we need to kind of bring that down to the level that more like a broader population can really work with and do some things good with.
Something I wondered about as I was reading your book, obviously machine learning is somehow part of kind of a scientific process. People are doing experiments, and we've all heard and read about kind of reproducibility crisis in a whole bunch of different kind of scientific subdisciplines. Where does reproducibility fit into what you're talking about and what you've been writing
Mhm.
about?
Yeah, that's a great question. So, yeah, I mean, if you're using a machine learning model to manage some business process, whatever, hiring or loan approval or what have you, uh, I, I mean, it's a different sort of reproducibility than in scientific discovery, I would say, because when you're conducting some science experiment to figure out some new sort of understanding of the world, you want to make sure that that understanding has external validity. It would hold up I mean, more generally than just the experiment that you ran and so forth, and would have internal validity so that even in that limited sort of scope that it would be able to reproduce those results, right? So the same sort of, I mean, ideas apply for using machine learning in other tasks, but since you don't necessarily, I mean, the internal validity, sure, I mean, exactly, you want the same sort of thing. The external validity is a little bit different, I would say, because you're not trying to necessarily discover like the laws of gravity or whatever. You're just trying to apply these systems in your setting to make sure that, in terms of the clients or the applicants that you receive, that the models are doing the right thing, right? So, I mean, the transparency, the documentation, the fact sheets that I was talking about can certainly help with a lot of those reproducibility sort of things. But I do think we want to make sure that we don't broaden the nature of the external validity beyond what we actually need for a lot of processes.
So it's almost a downstream consequence of some of the rest of the things that you've been talking about.
Mm-hmm. Yeah, absolutely. So, yeah, I mean, I think as long as we're kind of maintaining the right provenance, capturing the documents or the facts that we need for understanding what was done, then I mean, it's helping with the trust aspect, but it's yeah, I mean, just as much helping with the reproducibility.
Where are the kinds of places, maybe not even specific places, but what kinds of companies do you feel are getting things right in this respect? Is it very, very large companies with a lot to lose potentially? Is it small companies who care a lot? Yeah.
Mm-hmm. Yeah, I think it's a mix. So, yeah, I mean, in certain geographies, certain industries, there's definitely companies that are ahead of the game, especially those that have traditionally been regulated. So, in the financial services and so forth. But there's examples, both big and large, in all sorts of other industries that are pushing on trustworthy AI, trustworthy machine learning quite a bit. So I don't think it's necessarily based on the size of the company. I think it's more on the mission and whether uh, I mean, the decision makers, the people in power in those companies actually are devoting resources to focus on the trustworthiness aspects. So I think that's more of the reasoning behind it. But yeah, I mean, regulation, like I said, is also driving things.
Hmm. And we have all of these different roles in machine learning and
Mm-hmm.
kind of just doing things with data in general.
Mm-hmm.
Definitely following along from, don't take shortcuts, I guess,
Mm-hmm.
is don't just create some like token role for someone who's meant to implement trustworthiness for your machine learning. If we take that to its kind of conclusion, does that
Mm-hmm.
mean does that imply a kind of a rethinking how kind of the process is currently being implemented?
Yeah, maybe. So going back to the previous point that you were making about automation, right? If we imagine a few years into the future, presumably the feature engineering, modeling, and the monitoring and so forth are going to be automated. So we don't necessarily need people in those roles anymore, right?
Mhm.
So the roles that we need people for are the initial parts and the evaluation part, like I was saying before. So the role itself of defining, translating what the business problem is into a technical problem, that's always been a role that we need. I think it's just going to get heightened as the other roles get more automated out. So I think what we need to make sure about is that the people who are setting up the problems, that are figuring out what it is that we're actually doing, are thinking about the right things, that they are thinking about robustness and fairness and explainability and so forth. Because at some level they can be in their own bubble and not even care or think about like what the big effects of their systems could be. So the more we can bring that thinking right at the beginning, I think it'll be helpful. Because and even if we forget about automation, right, any skilled data scientist, if they're given requirements, they will meet them. I mean, people are I mean, able to do that. There's no question about it. So it's about kind of setting those KPIs, setting up the requirements and so forth at the beginning. That's the place where we need to really focus, I think.
Yeah, I'm wondering a little bit like what a platform built for fairness and
Mm-hmm.
social good like
Mm-hmm.
even looks like. There are so many kind of ML platforms, and
Mm-hmm.
particularly now with this kind of booming explosion of tooling in MLOps and so on. What you're envisioning, does it resemble what we have right now? Does it require
Yeah.
something different?
No, I don't think so. I mean, I think the MLOps way of doing things is the right way. Yeah, I mean, spending the time and having the tooling to think through the different stages, having some continuity across the stages that can get enabled. I think that's right. I mean, having the monitoring observability sort of infrastructure, I think, is going to be the right ways to do it. So, no, I think. the MLOps approach is the approach that just needs a little bit more sort of dimensions, but I don't think the flow itself needs any change.
And I presume that there's other non-technical shifts which need to happen as well. Imagine particularly in kind of the beginning of the process, even education and people coming into this space. How important do you see that relative to the technical changes?
Right. So I think you kind of mentioned it before. I mean, there's a large number of people coming into the space now that are coming from all sorts of different backgrounds. And so if they are bringing their background along with them, it's actually a good thing, right? There's people who have thought about it, who have personally experienced things that are kind of oppressive or harmful. There's people who are experts at kind of the nuance of what it means to have systematic sort of processes in place and so forth. So I think just having the right, I mean, those folks involved in this problem specification is already moving us in the right direction. And that's not to say that engineers and data scientists shouldn't also be kind of involved very heavily, because there's a lot of kind of imagination back and forth, a lot of translation back and forth to really figure out, I mean, what is XYZ concept from social science mean in a technical sense, and so forth. So, yeah, I mean, I think we're headed in the right direction. I think we just need some more time for this second 50 years to carry out, and then I think we'll be in good shape.
Yeah, I'm definitely in the moments where I've been on the practitioner end of things. I
Mhm.
definitely feel even something like the idea of testing, which is a kind of a relatively more or less well-defined concept in software engineering, is very fuzzy in the ML
Mhm.
world, and it's kind of
That's right.
yeah much harder to think about.
Yeah, I mean, testing, like you said, I mean, in typical software engineering, I mean, you kind of know what the answer is supposed to be, right? 2 + 2 = 4. But
Mhm.
in machine learning, I mean, the whole point is to generalize. So you shouldn't, I mean, it's not possible to know exactly what the right
Mhm.
answer is supposed to be. But there's clever folks figuring out how to test these systems. So one concept is called metamorphic relations. And it's the idea that if you know that two inputs are supposed to have the same output. You don't know what that output is going to be, but as long as both
Mhm.
inputs are supposed to have the same output, at least you can test that way. And there's all sorts of clever ways you can construct those pairs. So in a speech to text example, I mean, you kind of speed it up, slow it down a little bit. You can change the noise characteristics and stuff. I mean, you should still get the same sort of classification in a more fairness sort of context. If you have a tabular data set and you change a protected attribute, leave all the other features the same, but change, let's say, male to female or female to male or something, then presumably it should get the same output. So
Mhm.
there's, I mean, ways to do this, but I agree with you. I mean, kind of defining test coverage and these sort of things is to be figured out much more in the machine learning.
Your book is filled with a series of things that could make systems untrustworthy. It's almost like a catalog of the anti-pattern. But I get the sense that you maybe have an optimistic take on things, that it is at least possible, perhaps in theory, to solve them.
Mhm.
Where do you fall on the kind of the scale of how realistic it is that
Mhm.
we'll actually solve and fix some of the issues that you raise?
Yeah, I'm very optimistic, maybe to a fault. um, yeah, no, I mean, anytime you describe things that could be harmful, I mean, you have to describe both the bad and the good. Otherwise, you're kind of glossing over the important points. So, yeah, I mean, yes, you can misuse things, and that's true of a lot of technologies. But discussing them out in the open, suggesting solutions, and kind of going from there is my kind of optimistic ethos on it. Yeah.
And you mentioned we spoke a little bit about legislation earlier and how that might drive people to change their behavior and implement things or even drive the kind of the level of research or investment or whatever that gets put into this space. How important is that really? Because I guess people will point to something like GDPR and so on. And yes, on the one hand, it made people a lot more conscious about some of these things. But then again, maybe it just made us have to click cookie banners on every website. How much will that really drive change?
Yeah, I think the legislation itself, because it's written in natural language, it doesn't tell you exactly like that you need this metric to be this in this range and so forth. So it's less actionable than things that follow from that regulation. So I don't know in GDPR if there has been too much beyond just GDPR itself, but if you look at other industries, let's say emissions of cars or something, right? Then there's an agency created. They actually put numbers and do these tests and all of that. So I think we should look at other industries that have gone through additional regulation and kind of see how they've progressed. So I think the law is more of about just kind of getting the thought process going, but it needs to be followed up then by an actual sort of agency that would do the regulation, the compliance, and all of that, and then that leads to a more sort of a precise ecosystem around it. So if things head in that direction, I think there will be much more of a control over what it is that we actually want.
Okay. So we generally close up these podcasts with a couple of questions, and I guess we'll tailor them a little bit to what we've been talking about. So firstly, what would be a quick win that someone, a practitioner in this space, can add to making their productionizing their models more trustworthy?
Yeah, so I would definitely recommend check out the open source toolkits that I mentioned before, AI Fairness 360, AI Explainability 360, and so forth. So they're governed by the Linux Foundation right now, and the websites that we have for them have a lot of tutorials and glossaries and reference materials. So that can be a quick win. They are written in a scikit-learn sort of paradigm, so it should be easy for a lot of folks to incorporate them into their natural workflows.
And what would be one part of putting a model in production that you think toolmakers should pay more attention to with regards to what we've been talking about today?
Yeah, so I think the governance aspect of it. So there are starting to be organizations, companies, the tool makers that are developing governance solutions, but I think much more can be done there because even if you have all these fancy sort of bias mitigation algorithms or adversarial defenses and things like that, drift detection approaches, until you actually have a systematic way of applying them throughout a life cycle, throughout the MLOps process, I think they kind of get lost in the shuffle. So the more we can be holistic about it, kind of go into the MLOps mindset that these are the processes, these are the personas, and this is what people need at those precise times, then we'll be able to better institute some of these trustworthy machine learning concepts.
Yeah, so it's not really going to help if it's just an afterthought, like tacked onto the edge of a system.
Exactly.
Yeah. Well, thank you very much for coming on. I really enjoyed our conversation, and I definitely would recommend to our guests that they check out your book. It's not long, it's very clear. Yeah, definitely a lot to be learned from it.
Awesome. Thank you so much for having me.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.